CircuitPython
For the CircuitPython Parsec today, I wanted to show you how to turn a Neotrellis grid into a scoreboard for your Wordle game. Could apply to other games, but if you play the New York Times game Wordle, or an alternative version of it, you will know that it is a 5x6 grid, which is scored with either blanks when you don't get a letter right, yellow when you have a correct letter but it's in the wrong position, and green when you've got the correct letter in the correct position. So when you play the game, you're usually given something like, let me copy and paste one here out of my chat. So here's a typical, you can see up at the top here, I'm just going to paste it in. So there at the top, you can see that's a typical grid you might get after playing the game. It'll say, okay, here's where your positions were. And you might want to copy and paste those and share them with your friends over text, so it has some functions for that. But if you want to stare at it all day long and be proud of what you did or live in shame and vow to do better the next day, you can use this to do so. So you'll see here I have a sort of simple pixel art program that I've created that uses the Neotrellis, or Mechatrellis in this case, grid, the buttons to record when you've pressed a button, a little bit of logic to cycle between either off, green, or yellow for the different states that the game can be in, or the answers can be in. And let's take a look at how this is done. You can see also I have part of the canvas here that's not used, and I just lit those up with sort of a pale blue. So what I'm doing in here, again, I am importing the Neotrellis as well as the multi-trellis library, and I have 4 of these Mechatrellis/Neotrellis boards stitched together over I2C with 4 different addresses, so I can treat this as one 8x8 grid. And then I'm going ahead and setting up some colors I'm going to use, a sort of mini grid within a grid. So I'm saying that my Wordle grid starts at upper left corner here, 0, 0, and is 5 wide by 6 high, so x, y, axes here, width and height. And then I create this array so that we can work within that, all of the possible positions within that. So I'm tracking the state of those with this array called Wordle grid, and that creates a 5x6 array so we can store values. Then I also have some helper functions like position to x, y. This will turn any 0 through 63 on this grid into an XY position, and I just use that to cycle through them at one point. Sometimes you'll use either the XY or the 0 through 63 in your code, depending on what's more convenient. And then I also have a little check here. When I press a button, I don't want anything to happen on this canvas, so I check to see, is the pressed button inside of the Wordle grid? So this checks to see the start and end position and compare that to the 5x6 row. Then we get the color for the state, so that you'll see here I set up a little set of black, yellow, green, and the canvas color. So the state can be either 0, 1, 2, or back around to 0, and then I've just correlated a color with those. We initialize the display at first by running through the full range and setting it to either the black or the canvas color. And then I have a function here which is called handle button. So what this does is when we're running the main loop, we'll sync up the Neotrellis and look and see, did a button get pressed? Was the edge rising? So when we press it, the edge rises, and we kind of ignore the drop down when we let go of the button. If it's in the Wordle grid, then we say the grid x is equal to x minus the Wordle start position, and the grid y is y minus the Wordle's y position. And then we go through all of them and set their colors, and you can see here, so Wordle grid y grid x is equal to the grid y grid x of the stored value. And then we can wrap through by doing this modulo 3. So that's what allows us to go, every time I press that, through one of those values. Then we update the LED for those colors, just checking to see this 0, 1, and 2, black, yellow, and green position. And then the setup here that I mentioned before, using this XY pause to XY, is what sets all of those at the beginning, sets these keys to be active so that we can press them. And then the main loop of this is just simply the Trellis sync, just like some of the other examples we've seen before. That's a convenience of the Trellis library, is that it can just wait for events to happen and then run the other functions. And so that is how we can set up a, let's do a very triumphant one here. Let's get it in, I've never gotten it in 1, but let's say we got it in 2. There's a triumphant Wordle score there. And so that is how you can set up a little toggling pixel art canvas or Wordle scoreboard inside of CircuitPython on the Neotrellis or Mechatrellis board. And that is your CircuitPython Parsec.